Hello everyone, my name is S.N. Patil. In this lecture, we will discuss Lagrange's interpolation, that is Lagrange's method for finding the nth degree polynomial. Okay. If the arguments with unequal space are given, then we use Lagrange's interpolating method. See, we have the x and y. X means x having x point, x0, x1, x2, in which the difference between x1 and x0 is difference x2 and x1. Throughout the difference, not a same. Okay, and these are their corresponding value. X0 corresponding value is y0, y1 is corresponding value of x1. Okay, so there are n plus 1 point is given. If there are n plus 1 point is there, then we get the nth degree polynomial. Let us see the formula. I am not proving here formula. The formula is x minus x1 into x minus x2 dot x minus xn. The same term write in denominator, only instead of x write x0. x0 minus x1, x0 minus x2 dot x0 minus xn into y0. See here, y suffix naught, then write here instead of x, x suffix naught, plus x minus x0. This is the second term, means related to x1. X minus x0, x minus x2 dot x minus xn. Now here instead of x, write x1. Remaining term as it is, that is x1 minus x0, x1 minus x2 dot x1 minus xn into y1, plus now this is the x2 related term. Okay, x minus x2, x minus x1. Now here x minus x3, x2 is not there. Okay, here in first term x0 is not there in numerator. Here x1 is not there. Here x2 is not there. Okay, dot x minus xn in denominator same. Only instead of x write x2 term into y2, plus now this is the nth plus 1 term. This is n plus 1 term, means xn is not there in numerator. That is x minus x0, x minus x1 dot x minus x suffix n minus 1. So there are n factor. Okay, now same factor write in denominator, only in first term instead of x write xn minus x0, xn minus x1 dot xn minus x suffix n minus 1 into y suffix n. Now here some important remark is here related to Lagrange's. Lagrange's formula can also be applied whether the values of x are equally spaced or not. Now here equally spaced means the difference between x1 and x0, x2 and x1. See, actually, we have already discussed in difference, forward difference operator, backward difference operator, means Newton interpolation formula, in which the we find xn is x0 plus nh. Okay, that is x1 is equal to x0 plus h. Okay, x2 is equal to x0 plus 2h. Okay, the difference between, see, the difference between x2 and x1 is h. x3 is equal to x0 plus 3h. Okay, so these are the values of x1, x2, and actually the actual value of x1 is x0 plus h, x2 is x0 plus 2h. Okay, so throughout the difference is same, that is the h difference. Okay, but right now here difference may be equal or not equal, then still we use the Lagrange's interpolation formula. Okay, now the second remark, if we change the role of y and x, then this formula can also be applied. Okay, the formula can also be used to split given function into partial fraction. We can write in terms of partial fraction also. Okay, let us take the simple example on Lagrange's interpolation for the 2-degree polynomial. Let's see. The question is, find the 2-degree polynomial using Lagrange's interpolation formula for the following data. Now this is the data. 2-degree means there is a 3 points are given. This is the x0, this is x1, this is x2. These are the 3 points. Means we get the 2-degree polynomial, and these are the value of y, means y naught corresponding to x0. This is y1, this is y2. Now see here, x0 is 0, x1 is 1, and x2 is 3, and their corresponding value y0. This is the y0, this is the y1, and last is y2. Y2 is 0. Okay, now we write the Lagrange's interpolation formula. See, in the formula, in general formula, we have seen if there is a n plus 1 point is there, then n plus 1 term is there. So here 3 points, then there is a 3 terms. Let us see how the 3 terms. See, 1, 2, 3. Okay, now in first term x0 is not there in numerator, x minus x1 into x minus x2. Okay, in denominator write as it is formula, only instead of x write x0, x0 minus x1 into x0 minus x2 into y0 plus. Now here x1 is not here in numerator, x minus x0, x minus x2, and same in numerator write instead of x, x1, x1 minus x0, x1 minus x2 into in numerator y. Okay, similarly plus x minus x0, x minus x1, x2 is not there in denominator, instead of x write x2, x2 minus x0, x2 minus x1 in, and the term multiply to y2. Okay, let us put the value of x0, x1, x2, y0, y1, y2. Okay, we substitute here the x minus x1, x minus x3, 0 minus y, 0 minus 1, 0 minus 3, and y0. Y0 is 0. Okay, now next, x minus 0, x minus 3. In numerator, sorry, denominator, 1 minus 0. 1 is value of x1. Then 1 minus 3 into y1. Y1 is 1. Okay, plus x minus x0. X0 is 0. X minus x1. X1 is 1. In denominator, the value of x2 is 3. 3 minus 0, 3 minus 1 into y2. Y2 is 0. The first term is 0. Okay. Last term is 0. Only remaining the middle term. Now here simply x and x minus 3. In numerator, 1 minus 0 is 1. 1 minus 3 is minus 2. 1 into minus 2 is minus 2. Okay, here x minus 3x. Okay, now here it can be written as, see, this 1 by 2. 1 by 2 is a constant term. We can write in outside, also we can write the minus sign, minus 1 by 2. Okay, we can write as a minus sign, we take the common. Then what is the remaining term here? See, this is the x into x square. X is multiplied here. Okay, so we take the minus sign is common. Sorry, here minus sign is here. Minus sign is here, and the remaining term is x square minus 3x. This minus sign is here. Okay, so we get this. We can verify also whether formula, whether the result is correct or not. We can put here 0. When we put 0 here, put x is equal to 0 here, then we get y is 0. Put x is equal to next value. The x is 1. Substitute x is equal to 1 here. 1. What we get? Y is equal to minus 1 by 2. The value of x is equal to 1. 1 square is 1 minus 3. And here 1. 3 into 1 is 3. Now 1 minus 3 is minus 2. Minus 1 by 2 minus 2. So we get plus 1. See, we get the 1. Now put the next value x is equal to 3. We get y is equal to minus 1 by 2. 3 square is 9. 9 and 3 into 3, okay, is 9. 9 minus 9 is 0. So we get 0. Okay, the calculated polynomial is correct. In this way, we can verify. Okay, now let us take the second example of the same kind, 2-degree polynomial. Okay, find the quadratic equation. Quadratic means 2-degree polynomial by Lagrange's interpolation for the data. There are 3 points are given. Okay, so this is x0, this is x1, this is x2. Their corresponding values y0, y1, y2. Now see here. Okay, by Lagrange's interpolation formula, this is y1. Okay, so this is Lagrange's interpolation formula for the 3 points. If there are 3 points, then there is a 3 terms. Okay, now here we put the value of x0, x1, the value of the x0, value of x1 is 1, value of x2 is 2. Sorry, y is equal to x minus the value of x1 is 1, x minus 2 in denominator. As it is, instead of x, we write x0. x0 is 0. 0 minus 1. Okay. 0 minus 2 into y0. y0 is 2 plus x minus x0. x0 is 0. X minus x2. x2 is 2. Divide by x1 is 1. 1 minus 0. 1 minus 2 into y1. y1 is 3. Okay. Now next, plus x minus x0 is 0. X minus x1. x1 is 1 in denominator. x2 is 2. 2 minus 0. 2 minus 1. And the y2. y2 is 12. Okay. Now simplify. Here we get in denominator, first we simplify the denominator, minus 1 and minus 2, that is the simply 2. Okay, this is the 2 and this 2 will get cancelled. Now we simplify the numerator. For numerator we can use the formula. Suppose we have the 2 factor x minus a, x minus b. Instead of x plus a, x plus b, you can also write is equal to. So here x minus a, x minus b means what? These are the 2 factors, that is x is equal to a is root and x is equal to b is root. The simplification is x square minus the addition of the roots a plus b into x plus a into b. We use this formula. So here 1 and 2. A is 1 and b is 2. So we get x square minus this minus sign, and a plus 2 means 1 plus 2, that is 3x, and 2 into 1, that is 2. Okay, now plus. Now here simply x is here. So we can direct multiply x to x minus 2, that is x square minus 2x in denominator 1, and this minus 1 minus 1. Okay, 1 minus 0 is 1 and 1 minus 2 is minus 1. Okay, into 3. Now last, again here simply x, and x is multiplied to the x minus 1 means x square minus x divided by 2 minus 0 is 2, 2 minus 1 is 2, sorry, 2 minus 1 is 1, and into 2, that is 2, here 12. Okay, so we get here, now here the 2 is cancelled, here 6 is remaining. Okay, here minus. Now construct the here x square, construct the x square term. Here x square, here minus x square, and here 6 times x square. sorry, this 3 is here. Okay, so plus 6 and this minus 3 and this 1. So we get here, just wait, this is 6x square. Take minute, x square minus 3x plus we write in simplified form 2. Now here 3 is here, that is the 3 is multiplied plus 3x square minus 6x. Okay, now here 6 is remaining. 6 is remaining means, oh sorry, this minus sign, this is the minus and this is the plus, and the 6 is multiplied here, 6x square minus 6x. We get here minus 3 and a plus 6 plus 3 and 1 plus 3 and 1. So we get here 4x square. Okay, now construct the x related term, minus 3, okay, plus 6, see, plus 6 minus 6 cancel. So we get only a minus 3x. Now first we construct the x square term, now x term. Now the remaining only a constant term. There is only one constant term, that is 2. We get y is equal to 4x square minus 3x plus 2. Now let us verify whether the polynomial is correct or not. So first we put x is equal to 0. Put x is equal to 0. Okay. So what we get? When we put x is equal to 0 here, we get y is equal to 2. Okay. Now next value, put x is equal to 1. We want the 3. Let us see. Here 1, y is equal to 4 into 1, that is 4, minus 3 and plus 2. 4 plus 2, 6 minus 3. So we get 3. Right. Second also correct. Now the next, put x is equal to 2. We want the 2. Let us see what we get. Y is equal to, y is equal to, now 2 square is 4. 4 into 4, 16 minus 3 into 2, that is 6, plus 2. Okay, 16 plus 2, 18 minus 6, that is plus 12. Okay, we get the 12. Okay, so thank you for watching.